Extremes abound in the deep sea. We have investigated the ecosystems of this harsh environment and observed how groups of life cling to any energy source they can find, be it hot water, vents, or carrion. But now it's time to go even further down to find a spot where life is tested to the utmost. The Pacific Ocean seafloor spreads into a yawning pit of darkness at its bottom. Giants that resemble life from another planet, fish that don't seem to have faces, and vast bacterial fields. Let's explore the Mariana Trench's secret world in more detail. The famed Mariana Trench is a dip in the Pacific Ocean's floor that resembles a crescent, a fracture that is 2,550 kilometers long and 69 kilometers broad, and descends into a pitch-black hole. It contains the deepest known place on Earth at the bottom. The Challenger Deep is 11,033 meters, or 36,200 feet deep. The Mariana Trench drops into an area of the ocean that hasn't been extensively investigated at its deepest point. The area is called the Hadal Zone after the underworld of Greek mythology, the Kingdom of Hades, a fitting name for a location when the conditions are complete darkness, corrosive water, and limited resources. The lack of sustenance and extreme pressure make it difficult for species to thrive. It was thought to be a dead zone, devoid of all life for a significant portion of history, a non-starter frontier and a barren, dangerous vacuum that no human could ever cross. However, this was all about to change in the 19th century. The HMS Challenger crew discovered they needed more rope after casting a weighted sounding rope over the side of the ship in 1875, and this led to the discovery of the Mariana's depths. They had not anticipated a site to be so deep, but the news of its discovery drew their attention. Moreover, two guys went out to reach the bottom in 1960, 85 years after the Challenger Deep. Challenger Deep was found on that historic journey. Jacques Piccard and Navy Lieutenant Don Walsh were the only two people in the claustrophobic Trieste bathyscaphe. There were many difficulties throughout their 5-hour descent. Near the bottom, the water pressure was almost 1,000 times greater than the atmospheric pressure above sea level. The scientific community would be astounded by what they observed. Life. They saw white shrimp and fish that resembled flounders, as well as what they thought was a dark brown diatomicous slime covering the ocean floor. James Cameron, who had traveled in the same direction as the Trieste on the Deep-Sea Challenger in 2012, had also witnessed the bizarre-appearing filamentous colonies of microbes that were surviving off chemicals from the changed rocks 10,912 meters, 35,803 feet below the surface. Because larger animals cannot survive without sunlight, they must instead rely on the energy generated by bacteria engaged in chemosynthesis. It is these bacteria that support more complex creatures. In 1996, a Japanese submersible, led by the name of Kaiko, descended to a depth of 10,897 meters, making it the deepest dive ever made by an unmanned submersible. Its objective was to collect germs from the mats Piccard and Welsh had studied over 4 decades before. They discovered that several of these bacterial species looked to be obligately barophilic, which means they flourished under extreme environmental stress, disproving our belief that life could only live in more hospitable conditions. But when Kaiko went down to the Challenger Deep in 1998, she discovered a more complicated form of life. Hirondalia gigas is a species of enormous amphipod. This finding raised some intriguing questions. The amphipods and other marine species' calcium carbonate shells break down more easily in water under the intense pressures of the deep sea, leaving their sensitive bodies susceptible. As a result, amphipods are rarely encountered below 5,000 meters, 16,400 feet. A huge amphipod, however, was present in Kaiko's lighting and still had its robust exoskeleton. Since then, it has been discovered that they use a type of aluminum armor to defend their shells, employing chemicals in their stomach to absorb aluminum ions from the mud of the bottom while they hunt for food. These amphipods play a significant role in the environment as detritivores. They serve as a cleanup team since they have enzymes that can break down even wood. The holothurians are among the inhabitants that are most numerous. Sea cucumbers, such as the amazing sea pig, which uses its ring of feeding tentacles to sift through the mud and grasp hold of prey. Since it is believed that fish cannot exist in environments where the pressure is so high that it would disintegrate the bones of any vertebrates, some scientists think Piccard's fish was actually a sea cucumber. Despite several missions and footage, we have only just begun to scratch the surface of the Mariana Trench's secretive realm. Uncovering these new species will certainly help us solve the riddle of how creatures can endure such extreme conditions. The study of the Mariana microbes may help advance biotechnology and medicine, while also providing new insights into the origins of life on Earth.